In this video, we're going to talk about the integration by partial fraction. And specifically, we're going to focus on the linear factors, okay? Before we delve deep down into the problem, we should know that the integral of dx over x, or 1 over x, that happens to be the natural log of absolute value of x plus c. The integral of dx over x minus a, well, that's equal to the natural log of absolute value of x minus a plus c. And the integral of dx over x minus a squared, that is just negative x minus a raised to the negative 1 plus c. Okay. Now we need to remember this, okay? And so the general form now is given by, if we have some sort of dx for x minus a raised to the k power, well, that's just equal to 1 over negative k plus 1 times x minus a raised to the negative k plus 1, okay, plus c. So this is a general form that we should know. Okay, this is a general form that we should know. Okay, so that being said, let's start off. What if we wanted to integrate 3x minus 1 over x minus 3 times x minus 4 dx? Okay, how do we integrate it? Well, notice that our factors are linear. It's given in a linear form, and so immediately I could go ahead and distribute and decompose this. So we have 3x minus 1 divided by x minus 3 and x minus 4. And that is equal to a over x minus 3 plus b over x minus 4. Now, we need to get some form where we could set a plus b is equal to the numerator only. And how we do that is that we multiply by the denominator on the left hand side to both sides of the equation. And so if I multiply by x minus 3 times x minus 4 on both sides, okay, so this will be x minus 3 times x minus 4. And this will be x minus 3 times x minus 4. The idea is, well, x minus 4 and x minus 4 cancel out, so that leaves me with x minus 3. And x minus 3 and x minus 3 cancel out, so that leaves me with x minus 4. And you can see that we have two of the same thing on both sides, numerator and denominator, so those will cancel out, being multiplied. Okay, so the idea is that I'm left with 3x minus 1, and that is equal to a times x minus 4 plus b times x minus 3. Okay, now there's this beautiful trick we use only when we have pure linear factors, and it's the idea that because they're linear, I could get any value of x to cancel out one of these terms to leave me to only solve for one term. And so what do I mean? Well, if I set x to be positive 4, okay, if I set x to be positive 4, then 3 times 4 minus 1, because I'm going to plug in 4 in now for all my terms. 3 minus 4 is equal to a times 4 minus 4 plus b times 4 minus 3. And the idea is that we know 4 minus 4 is 0, and so we could cancel out one of those terms by setting x is equal to positive 4. Okay, and so doing that, we know 3 times 4 is 12, and we subtract 1 from that, that is 11. And we know this is 0, so we still have, well, 4 minus 3 is 1. So we got b. So literally we only have 1b, which is equal to 11. Okay, so that's the nice little trick about linear factors. And so now, look, I've gotten b. Well, how could I solve for a? Well, do the same thing. If I set b is equal to, it looks as if I said b is equal to positive b, those will cancel out. So if x is equal, well, not b, but if x is equal to 3, then I know plugging in 3 into the equation, this will be 3 times 3 minus 1, and that is equal to a times 3 minus 4, okay, plus b times 3 minus 3. We know this will go to 0. 3 minus 4, that is a negative a. And that is equal to 3 times 3 is 9, minus 1 is 8. So we know a is equal to negative 8. Now this was just divided by negative on both sides. Okay. And so the idea now becomes that now that I have my what a and b's are, I'm just going to go ahead and plug it in for the integral. So this is how we typically write it. We rewrite it as the integral of a over x minus 3, a over x minus 3, plus b over x minus 4 dx. Okay, so this is how we typically write it. Okay, now I'm going to skip pages, so let me rewrite that. So I rewrite it as the integral of a over, sorry about that guys, x minus 3 plus b over x minus 4 dx. And the idea is that now we're just plugging our values. This now becomes the integral of a, which was negative 8 over x minus 3, plus b, which was 11 over x minus 4 dx. And now we could distribute my integral sign, but I'm just going to do it in one step. Remember we said that essentially the idea is that, let me do it. If I factor out an 8 here, this becomes negative 8 times the integral of 1 over x minus 3 dx, plus, I'm just distributing my integral sign, plus 11 times the integral of 1 over x minus 4 dx. Okay, and the idea is, you can see that we know the integral of this. These are natural logs, okay? And because these were constants, I was able to factor them out. So this becomes negative 8 times the natural log of the absolute value of x minus 3 plus 11 times the natural log of absolute value of x minus 4 plus c. Okay, and this will be your integration. Okay, so that's the general idea behind kind of linear factors. Okay, so let's look at another one. What if we wanted to integrate dx over 1 minus x squared? Okay, well, it looks to me that this is factorable. So the first thing I look for is to see if it's factorable. If it's not, then we're dealing with quadratic factors. Okay, so we could factor this into 1 minus x times 1 plus x. Okay, so this is equivalent to this. And the idea is now that I could just go ahead and decompose. So this now becomes 1 over 1 minus x squared, and that is equal to a over 1 minus x plus b over 1 plus x. Okay. Now, the idea is, remember this is factorable. Okay? So this is essentially this. And so if I multiply by this on both sides of the equation, so 1 minus x times 1 plus x, and this is 1 minus x times 1 plus x. And I did not write this in the factored form, but again, I should have, but I'm not gonna mess it up. But hopefully you recognize that these and these are the same thing. And so these will actually cancel themselves out. And so when I look at this, well, x minus 1 and x minus 1, x minus 1. So we know that for a, this cancel out. So for a, so if I multiply, so let's do it. So this is 1 minus x times 1 plus x. Okay, and so notice that we have 1 minus x on both sides, so those will cancel out for a. 1 plus x is given out for b, and so those will cancel out. And so the only thing I'm left with is the fact that I have 1, which is equal to a times 1 plus x plus b times 1 minus x. Okay, so this is what I'm left with. So again, now, what do I want you guys to notice? Well, these are linear factors again. And so the trick is, well, if I set x to be -1, it looks as if I could get rid of 8. Okay, so If x is equal to -1, then we have 1 is equal to a times 1 plus a -1, okay, plus b times 1 minus -1. Okay, and notice that a 1 minus 1, this goes to 0. And so we're left with a 1, which is equal to, well, if we multiply these, negative times a negative is positive, so we actually get 2b. And so we know, dividing by that, we know b is equal to 1/2. Okay, so if that is the case, well, what about a? It looks to me as if I set, what about b? It looks to me as if I set x to be +1, then I could get rid of b. And so if x is equal to +1, then we have 1 is equal to a times 1 plus 1 plus b, which is equal to 1 minus 1, okay? And this goes to 0. And so essentially we have 1 is equal to 2a. And so therefore we could also conclude that a is equal to 1/2. Okay, so for this step, we can just go ahead and do our integration. So this becomes the integral of a over 1 minus x. Yeah, just want to make sure I'm getting it right. So a over, remember how we decompose it? It was a over 1 minus x, and then b over 1 plus x. So this is a over 1 minus x plus b over 1 plus x dx. Okay. And so now continuing, I just go ahead and plug in my values. So this becomes the integral of a, which becomes 1/2 over 1 minus x plus, well, b is also 1/2 over 1 plus x dx. Okay, and hopefully you could see by now I have a constant. So if I factor it out, I essentially just have 1 over 1 minus x. So the integration will be given by 1/2 times the natural log of the absolute value of 1 minus x plus 1/2 times the natural log of the absolute value of 1 plus x plus c. Okay, and so that will be your integral. Okay, so let's look at one more linear factors. Let's look at one more linear factor before we touch into another segment where we're going to look at quadratic factors. Okay, so what if I'm given this to integrate? 4x divided by 2x cubed plus 7x squared minus, this should be a minus 4x. Okay, how would we integrate this? Well, to me, it looks as if the bottom is factorable. Okay, they all have an x in common, so I could rewrite this integral as the integral of 4x over x times 2x squared plus 7x minus 4 dx. And I forgot my dx here. Okay, and so because those are factorable, well, it looks to me as if this x and this x would cancel out because they're being multiplied. And so essentially what I'm left with is some sort of integral where I have 4 over 2x squared plus 7x minus 4 dx. Okay, now again, now that I'm in this form, it looks to me as if this is factorable. And so if I look at this is also equivalent to 4 minus, well, what are the factors? Well, that looks to me as if it will factor into x plus 4 and 2x minus 1 dx. Okay, and so there's a reason why I put this problem here, because you see, before I actually even get to integration, I had to simplify. If I did not, then this problem would have become very, very atrocious. Okay, and so we need to be able to recognize how to simplify first before we even move on. Okay, so that's my idea behind this problem here. And so now that we in this form, we see that our factors are linear. Okay, and so essentially, if I multiply on both sides, I'm going to skip steps here since I did it, essentially. If I multiply by both sides, of x plus 4, 2x minus 1, then I'm going to get 4 on the top, and that is equal to a, okay, times, well, to me, and let's do it out. So this is 4 over x plus 4, and this is 2x minus 1, and let's decompose this into a over x plus 4 plus b over 2x minus 1. Okay, and so if we multiply by x plus 4, 2x minus 1 on both sides, then we're going to get 4 on the top to be equal to a times 2x minus 1 plus b times, well, b's missing in x plus 4. So this will be b plus x plus 4. So I hope everyone is okay with what I did. I just skipped steps there, okay, but essentially I just multiplied by the common denominator on both sides, and whatever cancel out will just give me the remainder. And so if I look at this now, well, to me, these looks like linear factors. And so if I set x to be negative 4, I could get rid of b. So if x is equal to negative 4, then 4 is equal to a times 2 times negative 4 minus 1 plus 0 plus b times negative 4 plus 4. And this will go to 0. Okay. Now if we simplify this, 2 times negative 4 is negative 8 minus 1. Well, that happens to be negative 9. So this is 4 is equal to negative 9a. So therefore, a is equal to 4 over 9, negative 4 over 9. Okay. And so to me, it looks as if I need to get rid of a to solve for b, well, if I set a to be 1/2, so x, well, I'm sorry, but not a, but if I set x to be equal to 1/2, it looks to me as if 4 is equal to a times 0, because again, 2 times 1/2 is just 1. 1 minus 1 is 0. 0 times a is just 0. So this is a times 0 plus b times 1/2 plus 4. Okay. So if I look at this, 4 is equal to, well, 1/2 plus 4. What is that? This is 9/2. So this is 9/2 b. Okay, and so therefore, if I want to solve for b, if I multiply by the reciprocal on both sides, well, b happens to be 8 over 9. Okay, and so the idea is if I multiply reciprocal on both sides, well, 2 times 4 becomes 8, and I still have 9 on the bottom. Okay, and so knowing that these factors are present, then I could rewrite my integral as a over x plus 4 plus b over 2x minus 1 dx. Okay, if I substitute the values, this becomes, well, a was negative 4 over 9, so this becomes negative 4 over 9, x plus 4 plus, well, what was b? 8 over 9, so this becomes 8 over 9, 2x minus 1 dx. Okay, and so to me, again, these are constants, so I could just, this should be my integral sign and factor them out, my integral is going to be given by negative 4 over 9 times the natural log of the absolute value of x plus 4 plus 8 over 9 times the natural log of the absolute value of x of 2x minus 1 plus c. Okay, and this would be my integration. So hopefully this video will help. Now we're going to talk a little bit more about quadratic factors in the next video.